Hello, it's Russ Curtis, and I wanted to talk about the normal distribution and particularly why we use t-scores and how that can help us. So hang out to the end and I'll tell you kind of a practical way I've needed standardized scores such as a t-score when doing research. And I don't think this needs to be as hard as sometimes it's explained, so I tried to clean this graph up a little bit. But with naturally occurring data, and for instance, let's just use height. If we were to get everybody's height, we would find that a very small percentage of people are probably, now I'm just guessing here, if we're looking at adults, a small percentage of adults are probably less than 5 feet tall. Okay, that would be in this area, 0.13%. And then again, a very small percentage of people would be over 7 feet tall. But the majority, 68%, over 68% would be right here in the middle somewhere, whatever that may be, 5'5" to 6'2", something like that. Okay, so let's look at this. If it helps me to draw kind of my y-axis here, but we've got our standard deviations, and so we are, one standard deviation above the mean, 2 standard deviations above, 3 standard deviations above, 1 below, 2 below, 3 below. And we like to standardize the score so that we can compare different tests measuring the same thing. And one way, the first way is to convert our raw score. Let's say you scored, well, let's say that you are 5'7". And what we're wanting to do is figure out where this falls in the range of standard deviations related to our sample as a whole. So we could convert this into a z-score by taking your actual height minus the mean height divided by the standard deviations. Okay? And the z-scores are broken down as to -3, -2, -1, 0 as the mean, then again, +1. You see all this. But what we have here is we have negative numbers and a 0. It can sometimes run into some calculation errors as we're using this to compare different test scores. So that's why we convert that to t-scores. A lot of this happens in behavioral health. And a t is simply the z-score times 10 plus 50. What that does is it just cleans those numbers up here so that we've got 3 standard deviations below the mean is a 20. 2 standard deviations below is 30, 40, and so on. So our mean is 50. Now let's look at the cumulative percentages, and that's what I want to do when we're looking at this 84.1%. Where did we get that? If we were to add the 0.13 to the 2.14 to the 13.59 to 34.13, that would get us 50th percentile, 50% of our data set here. We add another 34.13, and that's where we get the 84.1. Okay, so a t-score of 60, which is 1 standard deviation above the mean, as you can see that, is 84 is in the 84.1 percentile. And a way that we can explain this to folks is that if they were let's say they had a t-score of 60, and this is a depression scale, then they were they scored high at or above 84% of the sample that this was normed upon, or the reference sample is one way we can explain this when working with folks. And so that's what I just wanted to show is this relation that 1 standard deviation above the mean is a t-score of 60, and the percentile is going to be 84.1%. Now this is again very helpful. For instance, when I was doing some research, I was using 2 different depression measures. Well, each one of those depression measures were scaled differently. So depression on one of the scales was like 1 to 20, and on the other was 1 to 40. And so when you're trying to compare the raw scores when they're scaled differently, it's very difficult. But once you standardize these scores into a t-score, then you could look to see that, hey, I've got my participant A, let's call him John, and John scored, raw scores, on these two different tests look weird. I don't know how to compare them. But once we calculated the t-scores, I can say, wow, John scored, had a t-score of 61 on this first depression instrument and a t-score of 63 on the second one. And then we know that we're kind of in that general same area. And again, we always want to use multiple measures when we're assessing data. So it's nice to have two different depression instruments if we're using it. So let me know if this is helpful, and I look forward to talking to you on the next video. Take care.